This is All India Radio, Chennai. In our weekly program in English, we bring to you a dialogue on Milky Way, galaxy and beyond. SRIKUMAR, science communicator and editor of Ariviyal Palagai magazine, is in conversation with Dr. T.V. Venkateswaran, scientist, Vigyan Prasar, Department of Science and Technology.
Hello, listeners. Let's go to the first part of this program. What is all about Milky Way galaxy?
Yeah, it's a very wonderful question. In fact, the Milky Way in India, in Sanskrit, or in the northern part of India, it was called as Akash Ganga. In Tamil, it's called as Pal Vali Mandalam. Basically, in a very dark night, if you're in a rural area with no ambient light, you will be able to see the parts of this Milky Way galaxy. It will appear like a very thin cloud. But actually, if you have a telescope and look through it, I mean, you will be able to find thousands of stars. In fact, actually, galaxy is a cluster of stars, and our Milky Way galaxy has something like about 100 crore stars. And once upon a time, not very far ago, 1930s, people thought that Milky Way galaxy is the universe.
Okay.
They did not even know that there are thousands and crores and millions of galaxies outside Milky Way. They thought the Milky Way galaxy itself is the universe.
What is the solar system in our universe?
Yeah, so actually, if you look at this Milky Way galaxy, it's like a atom, okay? In between, in the middle part, I mean, it's slightly thicker, and the edges are like thinner. So you imagine one atom and another atom on it, put on the other side. Okay, so you will find a bulge in the center and thinning at the edges. Our solar system is not at the center of our Milky Way galaxy. Okay. In fact, it is almost near the edges. Okay, and our sun is going around the center of this Milky Way galaxy along with our planets, including Earth. It takes about 225 million years to go around once. And imagine, right now, Earth is in some point in space, right?
Yeah.
So, in the last rotation, when Earth was in the same place, there was no human on Earth.
My God.
And the whole of Earth was ruled by dinosaurs.
Okay. In that, could you please describe more about the sun and its planets, also the plasma nature of the sun?
So, let's start with the plasma nature of sun. That will be more interesting. We all know the three states of matter, something that most of us would have read in our school, right? You have solid, and then you put more energy, rather basically heat it, then it will become liquid, and then put more energy, then the liquid will become vapor, okay, vaporize. Now imagine you are going to add more and more energy into vapor. What will happen? That's a question that people started asking. And then they found, when they actually experimented, that atoms lose their electrons. So the electrons and the nucleus become separated. So they become a kind of a soup where the electrons and nucleus are together. This is called as plasma. On Earth, whenever there is a lightning, for movement, you will find this plasma, but the sun is full of plasma. And the interstellar space is largely made up of plasma. In fact, the whole solar system emerged from a huge gas cloud of plasma.
But normally we say it is a burning star. There are a lot of flames or fire.
Yeah.
But you're saying about plasma. So what is about nature of the sun exactly?
Yeah, see, when we generally say that the sun is a fiery ball, so then we imagine like a fire of a log, or a stove where we do our cooking and things like that. No, this is not the same kind of fire. It's a very figurative speech. Okay, so what's actually happening in the sun is what's called as nuclear fusion. Hydrogen, 4 atoms of hydrogen combine to produce a helium atom, and rather helium nuclei. In this process releases huge amount of energy. So that's how the energy is produced in sun. And what we call as fire on Earth is a kind of oxidization event. That's not what is happening on sun. So it is the plasma nature of sun which enables it to do this nuclear fusion. So that's the nature of sun. So if you actually speak from a scientific angle, you have to say that sun is a ball of plasma where nuclear fusion is taking place at the core because of the high pressure and temperature at the core.
How big our sun? And some scientists are saying that we can put 13 lakh earth into it.
Yeah, exactly. Imagine you are going to a shop with a bag and then you are buying oranges and putting into the bag. So imagine that you have a very big bag, something equivalent to that of sun. You can put 13 million earth into it. So it's such a huge one. In fact, if you look at the whole solar system, 99% of the solar system mass is in sun. So it's really very giant when you look at the solar system. So in comparison to sun, all the rest are just speck of dust.
Yeah, Carl Sagan was once said that our earth is just a dot of blue dot.
People also say that it's just a fourth rock from sun. That's all.
So what about the other planets in the system?
Yeah, so if you look at from current understanding, we say that including Earth, there are 8 known planets. We don't know whether there are planets much beyond. The chances are less, but only when you explore, we will know. So these 8 planets, and there are something like about 10, 15 minor planets, not exactly minor planet, dwarf planet. That is objects which have not grown into a full-fledged planet. And then there are something like 1 million solar system objects like comet and asteroids and so on. So sun contains about 99% of the total mass, but the remaining 1% of the mass is distributed into millions of pieces.
Okay. How big our earth, and people are saying, the scientists are saying that it's being protected by the Jupiter because of its mass and the gravity.
Yeah, it's a very important point. I mean, if you look at the early times of solar system, when the sun was formed, okay, there was a very huge gas cloud with plasma and nuclei of hydrogen and helium and other elements. They came together and then formed the sun. While it was forming, the remaining material, I mean, imagine you go to a place where there is a huge apartment is being built. Okay. So the apartment will be built. But if you go to that place, you will find some broken pieces of wood, bricks, used cans, all the remnants will be around, right? In the same way, when the sun got formed, because sun is 99%, imagine, right? So the remaining part, there were billions of pieces. So some of them collided, and then in the collision, they become smaller. Sometimes if they collide at a correct angle, they can fuse. Okay, so they can fuse and then grow. So that is how the planets came about. Okay, so there was a constant collision. It's called the bombardment phase of solar system. After that, somewhat stability emerged. After the stabilization, when the Earth became cooler and life started coming on Earth, if you have had constant bombardment, then life would have been very difficult on Earth. There is a constant bombardment on Moon. Okay. If you compare the chart of Moon, let's say about 10 years ago and now, you will find new craters, impact craters, some rock coming and falling on Moon. Jupiter attracts some of these material which are coming towards Earth, and thereby is a kind of a protector for it.
How can we differentiate this is the planet and that is the satellite?
Okay, so basically these are all definitions, but of course based on certain understanding of planetary dynamics. So a central star, okay, is called as a star, which is producing energy through nuclear fusion. It's called as a star. Any object which is going around it, which is substantial, it's roughly spherical in shape. And if that object does not have any other object in its surrounding, then we call them as planet. And if there is an object which is going around the star, but it is still there are other objects nearby, substantial objects nearby, then we call them as dwarf planet, meaning that it has not fully grown into a planet. And any object which is going around a planet, we call it as a satellite. So that's how the definitions are today.
Okay. And then there are inner planets and exoplanets. What is the difference?
Oh, okay. So inner planets are basically planets which are between Earth and Sun. So they are called as inner planets. And the planets which are beyond Earth are called as outside planets. Okay. Exoplanet is something different. Like Sun, there are also other stars, and those stars also have planets. So planets going around other stars are called as exoplanets.
Right. Then there is an interesting question that when we were a student, we were looking at Pluto as a planet, and now it is demoted and called as a dwarf planet. Why it happened? What is the...
Yeah, it's a very, very interesting question. A lot of people say that, why did you take away that thing from poor Pluto and things like that?
Yeah.
Okay, so it's like this. Bat can fly, yeah. But now when you study science, you don't call bat a bird, even though it can fly. You will say that it's a mammal.
Yeah.
Okay. Penguin can swim, but still, if you know science, you will not say that penguin is a fish.
No.
You will say that it's a bird.
Correct.
Whale lives in oceans.
Yeah.
Yet it is a mammal, not a fish, right? Why do you say that? Because now we have a better understanding of how life evolved, how every species evolved. So we know that, for example, the ancestors of whale were mammals which were living on the land. Ancestors of penguin were birds which were flying around Arctic and Antarctic, right? So in the same way, we now know how planets evolve, because not only that we have studied how planets evolve around the sun, but we have been able to study about planets evolving around other stars.
Correct.
We now know that there are different kinds of evolutionary path, and if a particular evolutionary path is taken, then it becomes a planet. If a different evolutionary path is taken, then it becomes a dwarf planet.
Right.
So now we know that Pluto is actually a dwarf planet. That's why we call it as a, not only Pluto has a companion called Charon. Together they are called as dwarf planets.
Yeah. So quickly tell us about what is nebula and asteroid meteorites.
So a nebula is a huge gas cloud, okay, which will have a mass of something like about 5 to 10 times the mass of sun, or even more. And some nebulas are even having 100 times, 1,000 times the mass of sun. And nebulas are basically the cradle in which new stars are born. So this gas coalesce and then become new stars. And asteroids and meteoroids are basically solar system objects. They are all remnants, leftovers when the sun form. They are all small pieces of rock which are going around in the space. And then if they are of substantial size, we call them as asteroid. If they go in a very highly elliptical orbit, we call them as meteoroid. It's called space rocks, basically.
So sometimes we see a tail-long star. Sometimes we confuse it. Is a star or something else. Yeah. So they call it comet. What is this comet? Okay, the comet is nothing but a space rock, which is 50% roughly volatile material like water ice and things of that kind, and remaining dust and rock. So when they come near the sun, because of the intense radiation of sun, a thin plasma tail is formed. Okay, the materials vaporize and then they remain in the space, so it appears like a tail. So a comet will have tail only when it is very near to the sun, not very far away. Okay, so it's nothing but a space rock with certain special property. That is 50% of them roughly is volatile material. That's it. Yeah. So very interesting information about all the Milky Way galaxy and the other planets. Thank you so much for this beautiful session. We close this session right now and we'll join you again in the next part. Thank you so much, sir. Thank you.
This is All India Radio, Chennai. In our weekly program in English, we bring to you a dialogue on Milky Way, galaxy and beyond. SRIKUMAR, science communicator and editor of Ariviyal Palagai magazine, is in conversation with Dr. T.V. Venkateswaran, scientist, Vigyan Prasar, Department of Science and Technology.
Hello listeners, again we are going to have another beautiful session with Dr. T.V. Venkateswaran. We are talking about the Milky Way galaxy and beyond. This part we are going to talk about many things. Right now I am going to ask a question to you, sir. What is this red giant?
Yeah, thank you. Last week we had a very wonderful discussion about some aspects of universe. Now let's explore a little bit more. I mean, some fascinating features of our universe. Red giant is a particular stage of stars. Okay, let's look at human. When you are born, you are called as toddler.
Yeah.
Okay. Then when you start crawling, you are called as a baby.
Mm-hmm.
When slightly you grow older, you are called as a child. Then adolescent, then a young person, then a middle age, then a old person, then a very, very senior citizen, right? So there are different stages in the life of a human being. In the same way, Stars also have evolutionary history. So when they are born as young stars. Then they grow, then they come to a middle age, then things happen. Okay, so not all stars have same kind of life, but a star like Sun, for example, has a particular form of life which goes into a stage called a red giant.
Right.
So if you look at our Sun was born about 500 crore years ago. Okay, so that time it was a very young star. It was radiating too much in ultraviolet. It was a very violet blue color star.
Okay.
Slowly it evolved and it is now in the middle age. So it means it has lived for 500 crore year. It will live again for another 500 crore year. Okay, so it's in the middle age. It's a yellow star now. So what happens? What's happening inside the Sun is there is hydrogen in the form of plasma in the core, which combines to produce helium. But then what will happen? Slowly the content of hydrogen will reduce, right? The percentage of hydrogen will come down.
Yes, it's burning every day.
Yeah. So then helium will go up, right? So at some point, there may not be enough hydrogen in the core.
Right.
And then the Sun will stop generating energy. That's when the red giant will form.
Okay.
That's a stage when the red stage comes. In human beings also, we know that new cells are born, old cells are dying, right?
Yeah.
So when you reach a particular age, that is when you become old, very, very senior, this balance becomes different. There are more cells dying and very less number of young cells are being born. Okay, so there is an imbalance. That's what we call as decaying old age, right? In the same way, when about 500 crores from now, when there is not much hydrogen in the center of Sun, okay, the Sun will stop radiating.
Right.
Imagine what will happen. Sun has gravity because it has a huge mass.
Correct.
So the gravity will be pulling every part of the Sun toward the center. Today, the radiation is balancing it and then the Sun is kind of stable.
Right.
So it's like tug of war. So there is one side the gravity is pulling, the other side the radiation is pulling. So there is some kind of a stability. Now when there is no radiation, the gravity will take over, the Sun will start shrinking.
Right.
Okay? Not every part of the Sun, only the core of the Sun will start shrinking.
Okay.
So if you have a sponge with the water, if you squeeze, what will happen? The water will come out, right?
Yeah.
So in the same way, when the core of the Sun squeezes, a lot of energy will come out. So the outer layer of Sun will expand. So at the same time, two processes will be happening. The core will be collapsing, not collapsing actually, contracting, and the outer layer will be expanding.
Right.
So when it expands, it will expand so big. That's why we call it as giant. Okay, and if you look at the surface, it will look red. I told you that today Sun is yellow.
Yellow, yeah.
When it was born, it was blue.
Blue.
Okay, so Vib jar. Okay,
Right.
so you start from blue, come to yellow, and then you will come to red when you are going to almost die. So the red giant will form. Okay.
Yes, that's the next question. I was also wondering about how the scientists calculate the Sun is going to live for next 500 crore year. How they do, and what is this red giant?
Excellent question. I mean, science does not just simply imagine. So you need to have some basis for saying that 500 crore year and so on. So now we are observing the Sun. We are looking at how much of energy it is producing. Now we know that when 4 hydrogen atom combine and produce a helium, how much energy it will radiate.
Right.
So now we know that how much of helium is being produced every second. How much of hydrogen is being consumed every second.
Yeah.
You know the size of the Sun. You know the size of the core.
Right.
So you can kind of calculate that how long this hydrogen will last. So from that you make an estimate that roughly it is about 500 crore year. Okay, so that's how the estimate of 500 crore year come. And then when the Sun becomes red giant, it will expand so much that it will first swallow Mercury. So in the beginning of red giant stage, there will be no Mercury. Then again it will expand and then it will swallow Venus. So then 2 planets are gone.
Gone. The next is ours.
Next is ours. Will Earth be swallowed or not? We are not certain. We don't know enough information
Right.
to say with certainty Earth will be swallowed or Earth will not be swallowed. But we are absolutely certain Mercury and Venus will be swallowed at that stage.
Right.
But much before that, Sun will be radiating so much of radiation that all the water on the Earth surface will vaporize.
Right.
Okay, so it will be a hellish situation. But don't worry, that's about 500 crore
Yes.
down the line.
Yeah. Is there any red giant right now in the universe?
Very, very good question. In fact, the nakshatra called as Trivadra, okay, it's called Betelgeuse in English, is a red giant, okay. It's roughly Earth will also become something like that. That's what. And that star is located some about 500 light year away. So, which means today, if we see the star, that light originated 500 years ago. So, by looking at what's happening in Trivadra, okay, so now some scientists are claiming that already Trivadra star has exploded. It's dead. But that news will come to us only after
500 years.
Kind of. I mean, if it dies today, then we'll get it after 500 years. But people are saying that it's already dead. So another 50, 60 years, we will actually be able to see that dying because the light will come to us.
Oh, great. Very interesting. And this white dwarf, they call sometimes white dwarf.
Yeah.
What is that?
That's excellent question. So now you may say that Trivadra will be dead. What will happen? What will happen is that basically the outer layer of Trivadra, that is the red giant, will explode and go into space. Okay, it will be called as a planetary nebula. Okay, but the center part will contract and become more even compact. So when it is contracting and becoming more compact, more pressure is generated, more heat is generated. So now helium can combine and produce other higher atoms. So we know from table, right, chemical table, elementary table, that hydrogen, helium, there is an order, right? So in the same order, new elements are produced. And then finally, it will come to carbon. So when the whole core is largely made up of carbon, the nuclear reaction will again stop. That stage is called as white dwarf, okay, because it will be very, very, very small. The sun will also become a white dwarf. When sun becomes white dwarf, it will be even smaller than Earth. It will be roughly the size of, greater Chennai. Imagine sun being squeezed to that level. Okay, so that's a white dwarf. And very interestingly, it's carbon. Okay, where do you see carbon? It's in charcoal.
Yeah.
Okay, then pencil as graphite, then diamond.
Diamond.
So the whole white dwarf will become a diamond.
My God.
So there'll be a very huge diamond in the sky.
Okay.
But only thing is that it'll be very hot, so you cannot go there and take a pickaxe and take some part of that diamond and come.
Yeah, I can go back to my school days like a diamond in the sky.
Exactly.
So we
That's
can
when the star will actually become like a diamond in the sky.
So it's a white dwarf.
Yeah.
And what about the black holes?
That's a very interesting question. So black hole is not a stage that sun will experience. So only stars which are about 10 to 15 times more than sun,
Right.
their life story will be slightly different. So they will not, after the white dwarf, it won't stop. After the white dwarf, further reactions will take place. And then in the end, it will become a black hole. So black hole is basically, the whole gravity is so great that it will implode on itself. And then in a sense, it will, in a flash of a second, it will completely vanish from the universe. We call it, mathematically, it's called as singularity. So basically, it will be an object whose escape velocity is the speed of light. So even light cannot escape it. So anything falling on it, it cannot come out. So that's what is essentially a black hole. Earlier, it was merely a speculation. People thought that there should be something called a black hole.
holes.
But today we know that there are black holes. For example, our center of our Milky Way is a black hole, which is having a mass something like about 1 million times our sun.
My God.
It's a very supermassive black hole.
And Stephen Hawking, one of the finest scientists lived in this planet, and he was talking more on the black holes.
Yeah.
Is there any study further going after Stephen Hawking's death?
Yes. So the nature of black hole. See, when we first thought about black hole, we thought that it will become a stage where nothing will happen.
Right.
So there'll be no more change. So Stephen Hawking thought about it and then said that no, there'll be change. So if a black hole is rotating, then it will be radiating.
Okay.
So if it is radiating, then it will mean that a black hole becomes smaller and smaller and smaller and then completely evaporate. Okay, so that even black holes change. There is nothing permanent in this universe. Everything is constantly in change. That's something that he found. And then there are very intricate properties of black hole about which he speculated some of them. People are working on it still. We need to know more about it.
Right. Thank you, sir. And one more question about the astronomy. Whenever we talk about the astronomy, people want to know more about aliens.
Yeah.
Is there any aliens in our universe?
Okay, I want to answer this question in two parts. First part is there alien in this universe? What is my opinion? Because it's only opinion, because I don't have evidence. Okay.
Right.
My opinion is that there should be alien in this universe. Life forming only on Earth is such a rare. I mean, that kind of a off chance is not something that appears to be very logical. There are billion stars in this universe. Many of them have planets. So you can't say that only right conditions emerged on Earth for life to emerge. Okay, so there should be life elsewhere in the universe. So all of them will be alien. So my guess, rather scientific guess or opinion is there is life in the universe other than Earth. But the second question is, whenever we talk about alien, people talk about UFO, that somebody saw like this,
Flying
etc.
saucer.
Yeah, that I don't believe. That again, I think logically does not hold water for simple reason. That is, let's say somebody gives you a ticket and then you go to, let's say Malaysia or New
Any
York,
country, yeah.
any country. You won't just land there, meet the first person and say hello, and then come back into the flight and come back to Chennai, right? You will stay there for a few hours, few days, you will go around, meet many people, eat their food, right?
Take selfie with them.
Yeah, exactly. So now if some alien species come to Earth, they would have traveled at least many hundreds of years, okay? Even if you go in the speed of light, to go to the nearest star, it's going to take you about 5 years, okay? So when you travel for so long, wherever you reach, you will stay for more days, right? So,
Correct.
but all the incidents of flying saucers and so on are momentous. They came, they landed, they just shook my hand and then they went back. So that's not very much believable. So there is a two different part to it. There is life elsewhere in the universe, but I don't think in the recent past they have visited Earth.
Really very interesting, that alien part. Thank you, sir. Thank you so much for this very interesting session on the Milky Way galaxy and beyond. It was, I hope our listeners at least understand or start with what is our Milky Way galaxy. Thank you, listeners. Thank you, Dr. T.V. Venkateswaran.
Thank you.
You just heard to a dialogue on Milky Way, Galaxy and Beyond. B. SRIKUMAR, Science Communicator and Editor of Ariviyal Palagai magazine, was in conversation with Dr. T.V. Venkateswaran, Scientist, Vigyan Prasar, Department of Science and Technology. This program came to you from the studios of All India Radio, Chennai.